All right, today I want to pick up where we left off last time. Last time we were talking about variables and literals and constants, but we also took a little bit of time and talked about input and learned how in C# we have to convert text into the appropriate type. Using an int.parse method that's built in for integers, there's a double.parse and a decimal.parse. There are others, but we don't use those types too much, so those recognize they're there, but we're not going to be using them. So either int, double, or decimal, depending on what kind of variable this is over here. Those three are all integers. So we did int parse. We discovered that if that text box has anything in it except an integer, int.parse chokes and it crashes the program. Before we're done, we'll learn how to deal with that. Done with Unit 4. But for right now, we're just going to be careful and not put any garbage in there. If we do, our program will crash and we'll go whoops, and we'll run it again. Int.parse doesn't like nothing. If you leave the boxes empty, that's not good. Put decimal places in an integer number, it doesn't like them. It literally crashes the program. We're not going to leave it that way, though. So that's where we left off. We now have all of our inputs transferred from this program. I go back to my design here. It says transfer, right. Transfer the bowling date and the 3 scores. So now finally, there's a lot of overhead here. Finally, we're going to start doing some math. Okay, so we had to declare variables. We had to transfer this. I didn't put this comment here. I'm going to put it in the recording. I usually put a comment here saying transfer the inputs to variables. It's mostly for you, okay, to help you remember what we're doing, and that should always be step 1 after you declare your variables, then transfer your inputs. That's what our design says anyways. Transfer the inputs. Then we can do the calculations. So today, how do we do calculations? Pretty straightforward. Right? C#, like most programming languages, has a bunch of operators that we can use. But first and foremost, remember that all programming languages transfer what's on the right of the equal sign. They do that processing and store it on the left. There is never more than one variable on the left-hand side of the equal sign. One of your classmates discovered that that's not true. It isn't my class. It isn't every single one of my programs. If you put 2 variables over there, it's just downright confusing. So we're not going to do it. The operators that we can use are the same ones that we've been discussing all along in pseudocode. You use a plus sign for addition, minus sign for subtraction, an asterisk for multiplication, and a slash for division. Many of you are working on your math program, and in the math program it shows a divide symbol, and somebody the other day said, I looked all over this keyboard. I can't find it. The little line with the dot above and below, it's not there. Not on your keyboard. It is a character that your computer recognizes. It's extra credit in chapter 4 for you to figure out how to get that in there. I should and I will remove it from the design because there it doesn't make a lot of sense. Okay. But if you can figure out how to get that divide symbol in there, that's extra credit in Unit 4. When we were designing, many of you told me about the order of precedence. Don't be shy. If you don't know what I mean by order of precedence, please raise your hand. Okay, so I'm not going to talk about it too much. I'll go through it pretty fast. Order of precedence says when we do math, we do multiplication, division, modulus. Percent sign is the C# operator for modulus. Right? Remember, modulus is the remainder. We're going to talk about that here in just a second. But those 3 all have the same rank. Those are not in any order of precedence up there. Just because multiplication is listed first doesn't mean it's done first. They all have the same rank. And then in an equation, any addition and subtraction is done. If you need to rearrange that, you want the addition and subtraction done first, and use parentheses to override the order of precedence. Parentheses have the highest order of precedence. Anything inside the parentheses is done first. Within parentheses, what if I have lots of addition, subtraction, and multiplication? Then the multiplication is done first. The order of precedence still applies. Before we get into that much deeper, let's write those first two equations because there's really not too much to them. The first equation we want, now we're going to calculate the outputs. Those inline comments are real handy for dividing your code into chunks. In this case, only 2, 3, 4 lines. But it makes code easy to follow. That blank line there also helps. You don't put that blank line in there, it's harder to read. It's not required. C# doesn't care, but we're talking about maintainable programs. According to my design, we're going to calculate the series. And that's equal to score 1 plus score 2 plus score 3. Can't be that easy. Looks like it. Really? What language am I in? Oh, there it is. Semicolon. Not there. I'm warning you in advance. It's been a day from heck for me. Nothing seems to work right. So if this class goes smoothly with all these recordings, I'll be surprised. That's it? How about that? We actually got a line from pseudocode that went directly from pseudocode into here, except for the semicolon. Everything else, we had to manipulate it somehow. Not that one. My design says calculate the average using parentheses. And remember, the design we built back in Unit 3 didn't. So let's write that equation without the parentheses. Average equals score 1 plus score 2 plus score 3 divided by 3, semicolon. That's also pretty straightforward from notes, or from the design, excuse me, but I promise you that one's not going to fly. And you'll see why in just a little bit. Syntactically, it's correct. We follow the rules. C understands what we're trying to say here. Even though we don't have the parentheses, C# is interpreting it different than maybe I am, but it understands, so that I can do that, and it does. So let's run that, but before we do, let's put a breakpoint down here on the curly bracket at the end. Mine's on line 46, yours should be nearby somewhere. If we run it, we can now look inside there and see what's going on. See if it calculates properly. We would expect not, right? Because we know we need parentheses because of the order of precedence. We're now going to prove that. So 101, okay, 100. I told you. 101 and 102. If you did this in your head, the total is 303, so the average is 101. That's what I expect. I could be using one of my test plans as well. I got to remember to remove the junk from the label here. I'm going to calculate, and my breakpoint is going to stop the program when I get there. No crashes. Everything's cool. I can look at the series, and it says, oh, 303. Cool, just what I expected. If it didn't, I would start touching these and make sure they're all the numbers that I expect. And this is the beauty of breakpoints and debugging, or debugging. We can hover using the mouse. I shouldn't say this is the beauty of debugging. Not all debuggers let you do this, but most of them today do. You can hover over a variable and see what its current value is. And so now we expect the average to be 101, and sure enough, it's not. So we can test this program. Somebody the other day said, why doesn't my program show any results? We haven't told it to yet. We're not at that part of the pseudocode where we move the contents of our results into the labels. Right now, it's just doing all this stuff behind the scenes. But because we're not transferring it to the labels, we have no way of checking to see what this is except using breakpoints. My advice to you is just put your breakpoint on the end curly bracket, run, and look around, and no, that's not right. Well, how about this? Yep, yep, yep. And the 3 can't be wrong. It's just a literal, right? So there must be something wrong with my logic, and you already know what it is, so I'm going to stop the program and correct it and see if that solves my problem. Can leave the breakpoint, add the parentheses. Breakpoint's still there, so now when I run, type in some numbers, and before I forget, you know, this is another thing we can do. I put some stuff in the labels here for testing clear. I left it, so I'm going to clean that out real quick. Those are cleaned out. You know what? I'm getting sick of typing numbers in there already, and I've only done it once. And we're going to be testing this program over and over and over again. So why don't we just put some numbers in here? Like 100 and 101 and 102. That way they'll already be there, and I won't have to type them. Just for testing. When you do that in your programs, don't forget this is just for testing. Before you turn it into me, get those out of there. Enter. And now I can run. And I don't have to do anything but say calculate. And if program pauses. Series shouldn't have changed, didn't. Average should be 101, and now it is. Really? Oh, yeah, 101. So calculations are probably the easiest part of this chapter. So far. Oh, didn't we declare a constant called games per series? Yes, we did. So that 3, the little hairs on the back of your neck were supposed to be standing up. Right, because we're typing in a literal. Whenever you type in a numeric literal, a number like that should make you nervous. You should stop and think, say, should I make that a named constant instead? In this case, to improve the readability, we said yes. To improve readability, not because we have to. It obviously works without it. And I wouldn't even suggest that you do it because the number of games per series isn't going to change unless we come up with some of those stupid rules I talked about last time. It isn't probably going to change, but it might improve readability, and we need some experience. So there's games per series. I've changed my program. I really ought to notice it let me change it while I was running. That's weird. Why? Because I'm at the end of the method. Often it will not let you change while you're running, so now I can just say run again and calculate. Games per series is 3, average is still 101, we're good. Whenever you change your program, even the simplest changes, my advice is test. And that's why I type those numbers in, so I don't have to keep typing them in my input boxes all day long. Okay, so we did that. Back to the notes. Equations with more than one operator are processed in the order above, this way. Parentheses override, yeah, we know that. Here's an example. 15 minus 6, that's 9, divided by 3 is 3. No, it's not. And your brain just does that if you're not careful. Division has a higher order of precedence than subtraction in my list over there on the previous page. So this gets done first. We take 6 divided by 3, that's 2. Then subtract the 2 from 15 and get 13. If you wish, you can use parentheses to override the order of precedence. Now the answer is 3. Here's another example. 15 divided by 5 times 3. Which one of those has precedence? Pardon me? 3? Is that what you said?
You said division.
Division. Why? I'm sorry, it's been a long day. I can't hear. Order of precedence. Really? No, it doesn't. Order of precedence said multiplication, then division, then modulus. Well, let me talk you into it. That's not what it says. That's why I have this example in here. These 3, and Mike was paying attention, all have the same rank. If they all have the same rank, they are processed simply left to right. If they all have the same rank. So what was done first here? This. And then we added 3, because they all have the same level or order of precedence. What was done first here? The parentheses. But inside the parentheses, this was done first, then that, with addition, doesn't really matter. Then we took that whole thing and divided it by 3. So in this example, order of precedence said there really is no order of precedence in that example because they all have the same rank. So we process them left to right. 3 times 3 is 9. If we wanted the answer to be 1, then we have to have parentheses around those because that's going to be done second. Here's a kicker. One confusing, and this is dangerous, happens a lot. That's why we test, why we write test plans so we can anticipate some of this stuff. One confusing feature of C# is how it handles integer division. Integer division means dividing one integer by another. That includes the longs and the bytes and the shorts, not that it matters to us. But when you divide one integer by an integer, C# always returns an integer. The answer is an integer, a whole number. What happens with the decimal places? Discarded, pitched, gone. Ew. Total age, let's pretend it's 226. I added up 10 people's ages, 256, excuse me. And there's 10 students in that class. 256 divided by 10 is obviously, I hope, 25.6. Average age is 25. Whole number, 25. Because this is an integer and this is an integer. What if this is a double? Then it's 25.0, but it's still 25 because this math gets done and it's integer divided by integer. C#, most curly bracket languages chop off the decimal places. Boy, that one will catch you if you're not careful. Even if this is a double, it chops them off. If you want to retain them, let's save that for a second. We have the same problem here. I do. The average is 101.0. That's the right answer. It's even a double. But what happens if I change this score to a 3? And calculate. Now it's 105. The average should be 101.66666. 101. You look at this and go, 101, what happened to my 0.66666? Integer division. This is an integer, this is an integer, this is an integer. When you add integers, you get an integer. This is an integer. So now we're dividing 305, an integer, by an integer. C# by definition, stupid C#. C# by definition gives you a whole number and it discards any decimal places. Oh boy. Good thing we had a test plan, right? And you tested it and the program comes back and it says 101. You go, no, it's supposed to be 101.6. What's going on? And you go back and you start sorting it out. 100, yeah. 101, yep. 102, yep. 3, yep. It ain't helping you much, is it? This is one of those where you look at it for a half an hour and you email it to me and say, Volker, what's wrong with this? And I say, is that a double? And a half hour back later, you say, yep, that's a double. And a half hour later, I checked my email again and said, that's a double. Are these all integers? Yes. I ask you that question and I probably never even get a reply. Because at that point, you go, oh, geez, they're all integers. That's integer division. I'm going to lose my decimal places. How do we fix it? You fix it by typecasting. We talked about that just a little bit last time. Remember there was a numeric up-down that was sad because we said, give me your value. And it said, no, I'm not doing it because this is a decimal. And so I said, you typecast it, meaning you on the fly change its type from a decimal to an integer. This is how you typecast. It's called typecasting. You temporarily change the type of a value. So that's how we do it to solve our integer division problems. The solution is not make one of these a double. All right, that's a very common question and a very common assumption that some people do, that I need this to be a double. So you know what? Let's just to make it easy, let's change score 1 to a double. Wrong answer. Now you've confused the maintenance programmer because he's looking at it go, bowling score? Double? How come? I can't think of any reason. So they changes it, makes it an integer, and now your program doesn't work anymore because you didn't deal with it where you should have. And so changing the type of your variables is not usually the answer. We picked the right type. Bowling scores are integers. The series is an integer. The games per series is an integer. Those are all the right types. So you don't change their types. Instead, you typecast. So we are going to change one of these, one value is all it takes, just one, into a double. I don't have a problem here. The problem is here. Okay, this total is still 305. That's correct. It's when I divide. And here's another thing. Try to get it into your head if you can. The only time integer division is a problem is when you're dividing, hence the word division. Integer multiplication, no problem. Integer addition, no problem. Subtraction, no problem. Integer division is only a problem when you're dividing integers. So if you, that sounds redundant, but something to remember. You don't have to worry about integers when you're multiplying, only when you're dividing. And which program? Math program. You're supposed to do integer division. And in the math program design, it shows this backslash. There's no backslash operator. You now have to strategically think, okay, how am I going to do this division? I want to leave it alone. Let it do integer division. It'll do it without you telling it to when you translate it in Unit 4. We're getting a little ahead of ourselves. You don't tell C# to do integer division. You just give it two integers and it'll do it. What you have to be careful of is what if you want the double answer with decimal places, then you have to tell it. So where should I put that? In the past, I've done this, well, we have a constant. Just change that. Now it's a double. That's all? Well, let's find out. That's all I needed to do. Wait a minute. In the last recording, we said C# racist, prejudiced, type sensitive. Joke's getting old, so I'll stop using it. Okay. Why is it, this is a double, this is an integer. I thought it doesn't like to mix them. You cannot store a double in an integer. You cannot, I think you might be able to store an integer in a double. But for the most part, C# does not like mixing types. Unless it's doing calculations, then, what is this? Okay. And what it does, what C# does is said, wait, I have an integer and I have a double. I can't do that. In memory, they look different. I can't do that, but I will. So what it does is it automatically promotes these to doubles temporarily for the purposes of that equation only. It doesn't change them permanently. Converts them to doubles. Now this is a double and C# says, whew, now I got doubles and doubles. Does its math and you get a double. We're going to talk about mixed type math here in just a second. But that's no good because we had games per series. Somewhere I have to put a double. I'm just going to stick it here. The point there was if you change one part of the equation to make it a double, the rest of it automatically gets promoted by C#. My God, how do you keep this stuff straight? Practice. So now I've said add these all up and take the sum and turn it into a double. And then divide by an integer. C# goes, no, I'm not doing that. It makes this a double automatically. Some people would do this. Perfectly acceptable. I think it's redundant because C# would do it anyways. C# does that for you automatically. C# does not do mixed type math, but it knows how to do some simple conversions so that it can do same type math. So I don't do that one, but you may. Doesn't this go into my design someplace? Oh no. This is a programmer thing. Those programmers, they'll be good at this by then. They'll go, I'll bet he wants, this is a double. He wants decimal places. I better do a conversion here. It's a programmer problem. Doesn't go into the design. Does that work? Better test it. Notice I've been making all these changes while it's running. Just lucky. Now what do you got? Cool. I got decimal places. It's called typecasting. It's temporary. This is not now an integer, or a double, excuse me. It's still an integer, but for the purposes of that equation, the total was converted to a double. For the purposes of this equation, C# converted that to a double, just for this equation. Here's a very common mistake. take this total, which is 256, divided by 10, and turn it into a double. That gives me 25.6, right? Order of precedence. Do the parentheses first. So this is an integer divided by an integer gives me 25. Turn that into a double. Okay, 25.0. Ouch. So the parentheses don't go around this whole thing. They go around one piece. That's what I did up here, one piece. Does make a difference. When C# is doing math in a big old long nasty equation, it does division first, right? Often. If those are two integers, it gives you an integer. You just lost your decimal places, even if there's doubles in the middle of the equation someplace. Let me see if I can work one up here for you. Put it on the screen instead of on the board. Accessories, notepad. Okay, font looks like it's probably big enough. I'll make it bigger. Just as an example, order of precedence. You would think that this is going to be really hard and complicated because this gives me 33 and a third, 3333333, right? No, it doesn't. This is an integer. How do I know? No decimal places. This is an integer. No decimal places. This gives me 33. And it's done first. Then I add the 2.5 and the 5.6. You get a double, and it has some decimal places in it, but the decimal places from here are lost, which is different than this. What do I do first? This, double, integer. C# goes, double, turns it into 100.0 so it can do math. So you get 102.5, double, divided by 3. I'm going to get decimal places because I've got a double divided by an integer. Oh my God, really? This is hard, confusing. Yes, you have to look at every pair of operands, they're called. Every pair of operands, that's the only undo I get, ugly. Every pair, we do this first. Highlight it, do something when you're doing these. If they're integers, you get an integer. If you're dividing, you just lost your decimal places. Then we do what? This. Then we add the rest on. So it can be very complicated. You're going to get a chance to practice and mess it up and get corrected. Questions? Why does it have to be so complicated? It's programming. If it were easy, everybody could do it and not have to pay me. And I mentioned that some people like to do this. That's fine, it works. But if you leave this one off, I'm watching Trevor squint over there. If you leave this one off, it still works, this double. It still works because C# will not do mixed type math. It will automatically, if it can, convert types so that they're all the same type. Here we go, mixed type math. If an equation contains a mix of doubles and integers, C# will temporarily convert the integers to doubles. It can't take doubles and turn them into integers. Doubles take up 8 bytes. Integers only take up 4. But it's relatively easy for C# to take the 4 and turn it into 8. Just add a bunch of zeros on the end, after the decimal place, basically. And now it's got 2 doubles. When C# does math, all computers, when they do math, they literally do it bit by bit, ones and zeros, and they do some magic math with those. If they don't have the same number of bits, can't do it. So that's why it does the promotion. This might be a lie here. Okay. It's a bit of a simplification. Whenever you have equations that are of mixed type, C# will convert the smaller type. Bytes are smaller than shorts, are smaller than integers, are smaller than doubles, are smaller than decimals. the way they were listed way back when in this chapter. It will convert the small ones. It'll upgrade them, if you will, to the biggest type in the equation. I don't think that's true of decimals. It doesn't do it automatically if decimals are involved. We'll see. The smaller types are temporarily converted to the largest type, so we can create equations of all kinds and mix them up. And let me try something here. Average equals 10 plus 2.5 plus 3.50 m. What's the m? Decimal. Look at it. Said, nope, won't do it. Operator plus cannot be applied to doubles and decimals. To me, that doesn't make any sense. I don't quite understand why that doesn't work, but it doesn't. The decimal type doesn't play well with anybody. Doesn't play well with anybody. So to fix this, I actually have to take this and turn that into a decimal. This part right here, turn it into a decimal because C# will not turn anything into a decimal automatically. It's just another one of those rules that we have to remember, and I don't remember it, so I type in an example, or I type in my formula, I get red squiggles. Oh, one of them's a decimal, it won't change it. Are you happy now? Still not happy. Oh, this is a double. And that's what the equation says, or that's what the error message says, if I can get to it. Come on. Cannot convert. Now I'm trying to convert decimal to double. That means stick it into here. Before, it said I can't use decimals and doubles with plus together. They're not the same type. So that was a different answer. Change this to temp, and now it's happy. And this also demonstrates that, notice, I can declare a variable well after the others. Don't recommend it. I like to declare all my variables together. But I've seen some people do this. It's happy. Make a variable and immediately add these up and stick the answer into series. Cool. No, not cool. Where did you describe your variable? You didn't. Leave them separate. When you get to be an all-powerful, mighty programmer making big bucks, then okay, take some shortcuts. But from a maintenance standpoint, declaring and putting something in there right away, dicey, not terrible, but not great. Notice if this is a decimal, I want to test this. This is interesting. Let's try this. Let's take the m off. Take the parentheses out. This is a double, right? Integer plus a double plus a double. And look, it still says, I cannot convert a double to a decimal. Geez, that decimal type just doesn't want to, it does not play well with anybody. Now a different test. That's not what I wanted. Integer. Double. It can do it because integers are small, doubles are big, so it basically just takes a small one, makes it bigger by sticking a whole bunch of zeros on the end. It can do that. Why can't it do it for decimals? I don't know. My only theory is that decimals are stored in such a funky way in memory with their ones and zeros that we can't convert anything to it. At least not automatically. We can convert it, but just not automatically. These are integers. Can I stick that in a decimal? I doubt it. Don't you make a liar out of me. Oh, I did not know that. What is that telling me? That decimals and doubles don't mix. Decimals and integers? Sorta. Can I do this? Oh my God. So I have to change my rules. Decimals and doubles don't mix. It's like networking instructors and software instructors. They don't mix. It's a joke. Okay. Everybody else we get along with. Integers get along with decimals. I did not expect that, honestly. But doubles and decimals do not get along. You cannot put them in the same equation. You cannot stick one into the other if you're doing variables. That's bizarre. Didn't know that. Noted. Put that in my notes. So this part here, it says equations can include any mix of these. That's not true. Doubles and decimals cannot be in the same equation without typecasting the double to a decimal. You convert the double to a decimal manually, and then they play well together. But you have to do it manually. It's ugly. Yep. Here's some nice little tests here. Examples. If I add 5 or 2 plus 5 plus 10, that's 17, but it's a whole number 17. If I add 2 plus 5.0 plus 10, the answer is 17.0 because it's a double, technically. It's still 17. In our brain, it's still 17. But in memory, it's a double. If I add 3 integer variables together, I get an integer. Does this work, by the way? Yes, it's that integer double. They play well together. This temporarily gets converted to a double. That 10 temporarily gets converted to a double. Adds them up, gives me 17.0. Integer plus integer plus integer, no problem. Answer is an integer. Integer plus a double plus an integer. Temporarily converted, we get a double. Integer plus a double plus an integer, temporarily converted, we get a double, stick it into an integer. Nope, that does not work. Taking big, it's called a narrowing conversion. We're taking a big type. Doubles are big. What do I mean by big? How much memory do they take up? Okay. Doubles are bigger than integers. How do you take the 1 gallon bucket and put it into here? It won't do it unless you tell it, do it. That's some confusing stuff. So you're going to practice. On my website, under Unit 4, if you wish, you can play with the labs, but we're not ready yet. That's still another 10 pages down the road, probably next week sometime. Okay. But there is a calculations worksheet, and there is a calculations practice exercise. This one I don't grade because I gave you the answers. What I want you to do with this one is open it up and try to do the assignment. Open it up. I've been having wireless and internet connection problems today. That's part of the reason I'm having such a good day, I think. And it's still connecting. Open it up, come up with the answers, and compare them to the key yourself. If you can see what you did wrong, slap yourself upside the head and try to remember that and move on. If you can't see why the answer is what it is, then email me or talk to me in class or something and say, I don't get why this is 3.25 or why this is 3.0 instead of 3.25. I don't get it. And I'll explain it to you. This, on the other hand, is a worksheet that is homework assignment. It is a Word document. I already have it open, so you should be able to see where to go. Oh no, it's down here. There it is. Okay. Looks like this. Are these good variable names? Yes or don't answer. Yes or no. And if no, hey, pay attention. If no, tell me why not. Amazing how many people miss that. That's 1 point out of 10 for not telling me why it's wrong. Kind of small, a little bigger. That's all right. You can see enough. Here's an equation. What does it give me? 15 divided by 2. Those are both doubles. 7, 7.5, 7.5. Which one of these is the best answer? You can figure that out. 18 divided by 3, best answer. 21 divided by 6, modulus. If x is 5, it's not going to let me zoom in here. Let's do that one. There we go. If x is 5 and y is 6 and z is 4 and w is 3.5, what answer do you get for these? Call this one a code walkthrough. Pretend like this is a little mini program. A starts out of 3, everybody's an integer. B is 4, then we do a calculation, then we do another calculation, do another calculation. I want the final answer of E. E is dependent on all these other calculations. Declare some variables. Interesting. Translate this, B equals 10 times A, translate that into C sharp. Translate this. Whoa, what is that? Some math, and I hate math. It's a quadratic equation. You can't hate math. You gotta love the quadratic. No, doesn't matter if you love it. How do you translate that into C sharp? Be careful. Today plus 30, we'll learn how to do that. Here's another little mini program. At the end, what is the value of x, y, z, and w? And there's another little mini program. All of these testing basically your calculation skills. This is a worksheet. It doesn't have a due date yet. It will. You can start it whenever you wish because you have most of the background right now. Most. The other one's practice. You might want to do that one first, see how it goes. Did it ever open? Yes. Okay. Declare a variable. Assign a value to that variable. Declare a variable. Assign another variable to value to it. Here's another little mini program. Run through it. What do you get? And so on. Here's some more equations. Geez. How do you translate that to C sharp? How do you translate that to C sharp? Those are practice. The answers are in the key that are on my website. You can start those anytime, but I'm not assigning a due date yet. There's no due date for the practice. That's just you. Whoa. Modulus. Let's do this and we'll take our break. The modulus operator is the remainder. I think most of you have already asked, or we've had a little mini lecture someplace that describes it. Modulus means remainder when you do division. Right, what I'm going to draw it on the board. It's not going to work well for the recording, but I've drawn it for just about everybody. Way back in elementary school, you learned to do division like this. 77 divided by 6, and if you're a second grader or third grader, since we're moving back in time, 6 goes, or was it 12? 12, sorry. 12 goes into 77 6 times. So you wrote the 6. And then you went 6 times 12, that's 72 with 5, doesn't go in there, with a remainder of 5. Remember that? A long time ago. Aaron remembers it, probably longer for him than many of us. Not me. I still do it that way. This is modulus. That's the answer for modulus. Sam, you're squinting. Is you confused? No. Okay. So let's do a couple of practices, and I'll say them out loud so we can hear them hopefully in the recording. I think my voice is probably going over there. What if we did 20 into 110? 5 times, it goes in there 5 times, and I remember being in 3rd grade, 4 times that's 80, 5 times that's 100, 6 times that's 120, that's too big. 5 times, 100, the remainder, 10. Okay. Oh, I should have left that. Show you a common mistake. 100 with 10 left over, so the modulus is a half or 0.5. Oh no. In my world, modulus is only done on integers. It can be done on doubles, but that's really bizarre. Modulus is done on integers, so you don't get a double. You don't get a half. This goes in there 5 times with a remainder of not 10 divided by 20, but just 10. Very common mistake, because your brain's already working ahead. That's a half, cool, half, no, 10. 10 goes into 20. I'm sorry, backward. Yeah, 10 goes into 20. 2 times with a remainder of 0. 0 is the modulus. So here's what the equation would look like in C#. Answer equals 20 divided, this is another very common mistake. It's 10 into 20. If I was doing dividing, it's 20 divided by 10, right? In algebra, it's 20 divided by 10. This is pretty close to that. It's a very common mistake when you see this 10, 20 to do this. That's not right. It's the other way around. 10 mod 20 is not right. I'm doing 20 mod 10. 10 goes into, there we go, 20. This is what it looks like. The answer in this equation is 0. There's nothing left over, is what we're asking in modulus. One more. New equation. This is what you'll see on the worksheet. And if you're not comfortable with modulus, your job is to draw it in 3rd grade math form. This says 200 into 10. How many times does it go? It doesn't. 0, so that must be a remainder of 0. No. This is another very common mistake. 0. It doesn't go in. I didn't ask you if it went in. I asked you what's left over. 0 times 200 is 0. Subtract with a remainder of 10. Ooh. 10. I lied. One more. 1, 2, 3, 4, 5, 6, 7 divided by 1, 2, 3, 4, 5, 6, 7, 8. This number's bigger, right? How many times does it go into this little number? None. What's left over? That one. You can remember that. Simplifies a couple of equations. Some of you are already turning in your designs for math, and I'm getting modulus answers that aren't right. If you've already turned it in and you want to check your modulus answers and turn it in again, I probably have the grade to do it. Send it back to me. Questions on modulus? You'll get some practice in those worksheets. So, leftover. Here's one more example. Why would I even want to ask that question? Omelets. I have 77 eggs in my basket. I counted them. Okay? I'm going to put those in boxes, and I'm a farmer, so I'm going to put them on the road to sell them. But the leftovers, I get to use for my omelet. 77 mod 12, that's what we had up there. Leftover 5 eggs, I get to use those in my omelet. The rest of them go out on the street for sale. Some of you are doing the change maker design. I haven't seen any of them yet, but some of you I know are tackling that. What are we asking there? How much change? How many quarters, nickels, dimes, and pennies do you get? Okay, if I have $1.05 in change, I need 4 quarters. What's left over? Ooh, leftover, modulus. Use modulus if you're doing the money changer program. If you don't, you're doing it the hard way. It can be done in other ways, but you're doing it the hard way. I said break. Did I lie? Yeah, let's do that checkpoint real quick. 18. List the operands. This is just checking to make sure you were paying attention back in elementary school. The operands are what's on either side of the operator, in between. Summarize the order of operations. I think you all got that. Rewrite the following code so it does not cause an error. Where does it cause an error? This is a decimal double. Decimal double math. Uh-oh. So if I need to fix it, I need to change the double board length into a decimal. So right there, you put in parentheses the word decimal, and then it works. But this is, I saw this before class, and I thought I got to test that, but I didn't have time. But they're basically telling us that doubles and decimals don't play together. You have to manually convert this board length to a decimal so that it plays with this decimal, and then we can put it in a decimal. Okay. Result is a double. What's in there when we're done? Think about it. $14 divided by 2 is 7, right? 10 divided by 5, or 2, excuse me, is 5, plus 4 is 9, but this is a double, 9.0, technically. If you give me 9, I'll be happy because you got the right answer in math. Right? You didn't give me 7, you gave me 9. Assume result is an int. Parentheses, okay, now it's 70, right? Result is a double. 5 divided by 2, the double is 2.5, right? Mike? You nodded.
Sorry, reaction.
What's wrong with that? Nothing. But it's an integer divided by an integer. The answer is 2. Even though this is a double, okay, 2.0. This does integer math, throws away the decimal places whenever you divide integers by integers. We'll talk about this later. Now go ahead and take your break.